Every year, the world produces more than 160 million tons of gypsum, a mineral hidden beneath the Earth's surface that, after an intense transformation process, becomes the material that shapes the walls, moldings, and finishes we see every day. It is one of the oldest and most versatile materials in the history of construction, used since the earliest civilizations. But how is that fine white powder, the backbone of modern architecture, actually made? To find out, we go deep into one of the largest gypsum mines in the world to uncover its journey. Gypsum, or hydrated calcium sulfate, is a natural resource formed in sedimentary layers over millions of years in ancient marine environments. Civilizations like the Egyptians used it to coat their temples and seal the walls of their pyramids. Over time, its use expanded into sculpture, medicine, and modern architecture. Today, industrial gypsum production blends the legacy of those ancient methods with modern technology that allows it to be extracted, processed, and the land restored to its natural state, ensuring environmental sustainability. So how does a gypsum mine work? Everything begins with extraction. To reach the gypsum deposit, geological studies and drilling are carried out to determine the depth and quality of the seam, usually found between 3 and 9 meters below the surface. Heavy machinery then removes the top layer of soil, known as overburden, which contains no gypsum and is carefully stored for later restoration. As the machines advance, the ground reveals a bright stone layer that will become the foundation of the production process. Once the vein is exposed, excavators remove large blocks that are transported by haul trucks to the processing plant. The movement is constant, almost like a natural conveyor belt between the quarry and the industrial area. Each extracted rock is visually inspected before being unloaded in the storage area, where the mineral's transformation begins. Even at this early stage, there is a strong environmental commitment. Once a section of the quarry is depleted, the fertile soil that had been set aside is spread back over the land, allowing vegetation to return and the landscape to recover. It is a cycle that feels more like the land's breathing. It opens, is used, and then closes again to make room for new life. This is how gypsum begins its journey, from the depths of the earth to the start of its industrial metamorphosis. Once the mineral arrives at the plant, a simple yet crucial stage begins: natural drying. The extracted stones are spread across large concrete surfaces known as drying fields, where they are laid in an even layer so that sunlight and air can circulate between them. At first glance, it looks like a massive carpet of white stone shimmering under the sun, but in reality, it is the first step in freeing the gypsum from the moisture it carries from underground. The sun plays a vital role. Its heat evaporates the water trapped inside the mineral's pores and naturally separates clay and other impurities. As hours pass, the surface of the gypsum hardens slightly while the soil attached to it cracks and peels away. It is a patient process powered by solar energy, reducing the need for fuel or ovens at this stage. Some producers like to say that here the gypsum breathes for the first time, releasing the excess moisture that ties it to the earth. When drying is complete, the material undergoes an initial screening. Large, vibrating sieves made of metal separate the clean pieces from the clay, soil, or debris. Each vibration refines the mineral, leaving behind only the pure stone that will later become powder. The rhythmic sound of metal and gypsum signals that the raw material is ready for its next transformation. An interesting fact is that plants using this solar method can cut energy consumption in later stages by up to 30%. The climate becomes an invisible ally in the industrial process. With the gypsum now dry and clean, mechanical transformation begins. The stones are carried to a primary crusher, a powerful machine equipped with steel jaws that crush the mineral into smaller, manageable fragments. It is the moment when the solid rock begins to lose its original shape, turning into irregular chunks about the size of a hand. Inside, the sound is constant, a sharp, repetitive impact that sets the rhythm of production. From there, the fragments move into primary grinding, where massive rollers and hammers continue breaking the material down to achieve a finer particle size. This coarse powder will form the base for calcination, so its size must be precisely controlled. Feeders regulate the exact amount entering the hoppers, preventing overload and ensuring a steady flow. Before entering the mill, the gypsum passes beneath a permanent magnet, a small but vital detail. Its job is to remove any metallic particles, such as nails, tool fragments, or bits of machinery that may have mixed in during extraction or transport. Though invisible to the naked eye, this step preserves purity and protects the grinding equipment from damage. Inside the mill, the motion is rhythmic and relentless. Internal blades lift and drop the material repeatedly until friction and impact break it down completely. As the process continues, the gypsum takes on a texture similar to fine sand, ready for the next and most critical phase, calcination. Once ground, the gypsum enters the most delicate and decisive stage of all, calcination. This is where the mineral undergoes a chemical transformation to acquire the properties that turn it into the white powder we recognize. The material is fed into a rotary kiln through a conveyor belt that slowly moves it inside, beginning its metamorphosis. The kiln is a massive metal cylinder that rotates continuously on its axis. Inside, the stone moves from one end to the other as a stream of hot air envelops it. The system works in counterflow. The gypsum enters from one side, while the burner, fueled by natural gas, is positioned at the opposite end. This setup ensures gradual heating, preventing thermal shocks that could fracture the grains or affect quality. In the kiln's first section, the mineral reaches around 100 degrees Celsius, losing its surface moisture. As it moves toward the hotter zone, temperatures climb to about 180 degrees Celsius, triggering the key transformation. Natural gypsum, chemically known as calcium sulfate dihydrate, loses part of its crystalline water. This dehydration turns it into calcium sulfate hemihydrate, the essential component of construction plaster. In simpler terms, the mineral dries from within, releasing vapor and becoming ready to rehydrate later when mixed with water. Inside the kiln, metal paddles called lifters continuously stir the material, forming a curtain that keeps it in contact with the hot air. This constant motion guarantees even heating and prevents clumping or burning. Visually, it looks like a stream of sand suspended in the air, dancing to the rhythm of the heat. The system is designed so that nothing goes to waste. The gases and suspended particles generated during calcination are captured by a bag filter, a set of massive fabric cylinders that act like industrial lungs. As the hot air passes through them, microscopic particles are trapped, and the collected dust is reintegrated into the process. The only thing that exits through the chimney is water vapor, clean and free of chemical residues, a natural result of the mineral's internal evaporation. A fascinating detail is that despite the size and complexity of the kiln, the entire process remains balanced, thanks to precise temperature and time control. If the heat is insufficient, the gypsum won't dehydrate completely. If it's too high, it overheats and loses its ability to set properly. In a way, it's like baking bread. Too raw and the structure doesn't form. Too cooked and it hardens prematurely. Precision here is everything. When the mineral leaves the kiln, it's no longer the dull rock that entered. Its color becomes lighter, its texture more porous, and its weight noticeably lower. This is the semi-hydrated gypsum, the base material that, once ground and mixed, will shape walls, moldings, and smooth surfaces in buildings around the world. The stone has been transformed by fire, and from here begins the final stage of refinement. After calcination, the semi-hydrated gypsum enters the final refinement phase, the ultimate grinding. Here, the material becomes the ultrafine powder we all recognize. The cooled gypsum is conveyed through enclosed belts toward hammer or roller mills, depending on the desired product type. Inside these machines, the material is hammered and rubbed until it reaches an almost impalpable texture, comparable to the finest flour. This degree of pulverization is intentional. It directly determines the smoothness, setting time, and quality of the final product. Inside the mill, movement is constant. The blades spin at high speed, lifting small clouds of white dust that are drawn into ventilation systems and directed towards cyclone separators. These devices allow air to escape while the fine gypsum powder settles into storage silos. The process repeats continuously until the precise particle size is achieved a measurement that can vary depending on the intended use. Coarser powders for structural applications and finer ones for finishes and decorative mouldings. Once the ideal texture is reached, the material is classified and sent to different silos labelled according to its purpose. Some batches are reserved for pure gypsum, the traditional kind used for coatings or as a base in mixtures. Others go through an additional stage where specific additives are incorporated to enhance their properties. Added in precise quantities, these compounds can modify setting time, increase strength, improve adhesion, or facilitate mechanical application through spraying machines. For example, in single-coat plasters widely used in modern construction additives allow the material to be applied directly to walls without multiple layers or long drying times. It's a technical innovation that turns an ancient mineral into a product adapted to today's industrial demands. The final result is a uniform powder with a matte white colour and silky texture, stored in silos ready for packaging. At this point, the gypsum has completed its essential transformation. What began as a compact stone underground has become a light, versatile material precisely calibrated for modern construction. The final stage of the gypsum's journey takes place in the packaging area, where precision and efficiency are as vital as in previous phases. From the silos, the ultrafine powder flows through sealed pipes into automatic bagging machines. Each one measures and dispenses the exact amount per bag, usually 25 or 40 kilograms, ensuring consistency and uniformity. The gypsum falls like a smooth, white stream into the sacks, which are sealed instantly to protect them from moisture. The process repeats thousands of times per day. In a large-scale plant, production can exceed 130 tons daily, a steady flow moving to the rhythm of conveyor belts. Once filled, the bags go through a weighing control system and visual inspection to verify seal integrity and label accuracy. Everything is automated to ensure each unit leaves with the same precision as the last. Next, the bags are stacked on wooden or plastic pallets in the palletizing area. Robotic arms arrange each layer carefully, forming stable blocks that are wrapped in protective film. These pallets are prepared for distribution to warehouses and construction centres, where the gypsum will be used by professionals to shape walls, ceilings, and perfectly smooth surfaces. Behind each bag, beneath its simple and familiar look, lies a complex and coordinated industrial process that turns raw material into an essential component of modern life. Before leaving the plant, random quality tests are performed on samples, checking fineness, setting time, and material purity. These controls ensure the gypsum maintains the right properties for application without losing performance or stability. Only then is the product approved for distribution. But the process doesn't end at the factory. Once an extraction zone is depleted, the production cycle closes. The fertile soil removed at the beginning is spread once again over the land, covering the worked areas. Over the following months, life returns. Seeds germinate, vegetation grows back, and the landscape reintegrates into its natural environment. In some cases, the reclaimed land is used for crops like soy or wheat, and that's how millions of tons of gypsum are produced every year. Did you already know about this process? Let me know in the comments. If you enjoyed it, hit the like button and subscribe. In the windows you'll see next, there are more industrial process videos just as fascinating as this one. See you next time.